So let's take another look at types in C. Here's an expanded list of types. For numbers, first of all, for real numbers, we have the type name float, and we also have the type double. For integers, we have two types, int and long. And again, we have the type char, char for single characters, and these are enclosed inside of single quotes. There's no built-in type in C for strings. They're usually implemented as arrays, and we'll talk about this later on. There's also no logical type for true-false expressions. In C, when you have an expression that would be conceptually either true or false, the resulting type is actually an integer. It's actually int. And the way it works is 1 if the expression is true, 0 for false. So more on number types. Again, for real numbers, generally we use the type float. Double stands for double precision, and that's used when you need to store a larger number than what you could store in the type float. But usually for real numbers we use float. And for integers we usually use the type int. However, there is another integer type for longer integers, which is called long. Long is actually what's called a qualifier for the type int. So formally when you declare a variable, you would be declaring it as the type long int, but you can leave the int part out and you can just use long for the declaration. Now when you actually put a long number in a variable, you must have the suffix l. So for example, if I wanted the long integer 1, 2, 3, 4, 5, 6, I've got to say it as 1, 2, 3, 4, 5, 6, l. So that specifies that it's a long integer. Any type name can be used as a cast operator to convert an expression to that type. So the syntax is that you put the name of the type in parentheses first before the expression, and what it does is it forces this expression to be this particular type. This is particularly useful when working with fractions because of the way that the whole number division operator works. So for example, let's say we have a float variable called num, and if we said num gets the value of 1/2, we've seen already that that's going to store a 0 in the variable num because that's the whole number division operator, and we get 0 as a result, even though the variable is the type float. So if we instead use the cast operator, so again, if we declared the variable num to be float, but now, instead of just saying 1/2, we put the cast float before that. That says I'm forcing this expression 1/2 to actually be the type float, so I'm really going to get 1/2 out of that. So that's going to store 0.5 in the variable num. So that's extremely useful. This is what you always want to do when writing fractions in C, because of the way the whole number division operator works, is that you always want to cast them. So usually you want to cast a fraction to be the type float, so you actually get a float value as a result.